Mari. Hello, Nina. I don't know how to spell your name. Nina Mari Alilojo. Hello. How are you, Nina?
Fine.
Fine. Okay. From where are you from, Nina? Vietnam or Philippines? From Philippines. All right. Okay. How about our virtual summer school, Nina? How about our speakers and the lectures? Is it fun or there is maybe?
Yes, it is fun, and there are so many things that I learned in this session.
Okay. What the topic of your poster, by the way? Is it from food technologies or biomaterial or circular economy, Nina? What the topic of your team? Where is Nina? I think.
Sir, Mom, I have lost my connection.
Oh yeah, okay, it's okay. All right, thank you, Nina. Maybe I will like to say hi to Priya. Hello, Priya. Hello, Priya.
Hi, hello. Sorry, there's like delay in my internet connection. Yes, good morning.
Good morning. Bagaimana kabarnya?
Yes, I'm good. Hope you're like doing well also, the committee members.
Okay. Priya from Malaysia, right?
Yes, I'm from Malaysia.
Yeah. Okay. How about our virtual summer school program?
Oh, it was very informative, and I'm glad that I joined it because actually now is my semester's UC University semester break. So I'm like very glad that I joined this and used my time well.
Okay.
And I really like to say thank you to like organizing this virtual summer school as well.
Okay, thank you very much, Priya. And what the topic you like the most from our speakers?
I really enjoy the talk when they talk about innovation in food technology and as well as about the algae, the microalgae. Yeah, it was like insightful. Actually, every topic was insightful as well.
Okay, yeah, microalgae and food technologies, yeah. Okay, it's very interesting topic, I think. Okay, thank you, Priya. And I would like to. Okay, thank you. I would like to say hi to our student, maybe. Wita. Hello, Wita.
Hello, Miss.
How are you?
I'm good. Thank you for asking.
Okay, nice. Because Wita always asks to our speakers. It's a very nice. Thank you, Mita. And how about our virtual summer school? What do you think our virtual summer school program?
Great, Miss. I really enjoy it.
Okay. But the topic. Hello, Wita.
Yes. Sorry, my
What
connection.
Okay. It's okay. What the topic of your poster assignment?
About wastewater innovation technology.
Okay, all right. Do you did your poster assignment with other friends from UPI or other country?
in Indonesia, but other university.
Okay. Nice. So you have a new friends, yeah, from this session, from this
Yeah.
virtual summer school. Okay, nice. All right. Okay, maybe I would like to say hi to Afra Bias. I think it's from Malang, right? Hello, Afra Bias. I think she or he can join the audio maybe. Okay, maybe from Abdul Wahid. Hello.
Hello, Miss.
Okay. Hello, Abdul Wahid. Where are you from?
I'm from Bandung.
Oh, Bandung. Sorry. From UPI or other university?
Yeah, I'm from UPI.
Okay. I'm sorry. Maybe,
He is my student, Ibu Amel.
oh, okay. I'm sorry.
Hello, good morning, Abdul Wahid.
Good morning,
Good
Mom.
morning. Enjoy the event, yeah, Abdul.
Yes, thank you.
Okay. Maybe from the other university. Aslan Irunsa. Hello, Aslan.
Yes, ma'am.
Okay, Aslan, where are you from?
Actually, I just graduated from postgraduate last year.
Yeah.
And a few weeks ago, I accepted as a lecturer in one university, and I will be teaching next September.
All right. What university?
It is a Marine Institute.
Marine Institute. Okay.
Yeah.
In Indonesia or?
Yeah, in Indonesia.
Ah, all right. Okay. And what the major did you take for your postgraduate, Aslan?
Environmental chemistry.
Environmental chemistry. All right. So maybe we STEM, yeah, college, yeah. Aslan, we are a college, but different university. Okay, nice. Thank you, Aslan, for joining our VSS. Okay. All right. Could we start the meeting, or we still with other participants? It's already 2020, yeah, maybe around 20 participants.
Yeah, maybe we can start, Mel.
Okay. All right. We will start. Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay. Good morning, everyone. Welcome back to our virtual summer school program, Green Sustainable Chemistry for a Better Future. How are you today? I hope that all of you are in good health and still have enthusiasm to take part in this virtual summer school closing meeting. I'm Amelinda Pratiwi, will be your host for today's session. So it doesn't feel like it's already been a week, yeah, since we attend lecture from 11 speakers, both from Indonesia and also from international speakers, who has provided materials on sustainable development goals so that we can gain a lot of knowledge and also can expand our insight related to current condition of our Earth and how to deal with several problems such as zero hunger to several innovation of food technologies. And from the energy side, we got knowledge from renewable and clean energy and how to overcome the climate change or global warming by reducing carbon emission, circular economy, biomaterial and biocomposites. And also we got some knowledge related to innovation water treatment. Okay. And last but not the least, I would like to express my appreciation to all of the participants who have attended this virtual summer school program since the first day until today. And thank you for all of the active participating in those lecture through the active asking the question to the speakers, and also active join our quiz session. And the special thing is you already did the poster assignment, and actually I've checked all of the poster and it's a very beautiful and it beyond my expectation actually. So I'm very excited to see your present the assignment. Okay. All right. Maybe the committee can share the PPT. I would like to read our today's agenda. So, should I? Okay. Thank you very much, Bu Tri. Yeah. For today's meeting, next slide. For today's meeting, we will have some session. The first is opening, and then we continue to the presentation of the group. And next, we will continue to the appreciation for the participants. So make sure all of you give the best presenting your assignment. Okay. And the next, impression and testimonials from the participants. And the last agenda is closing. All right. Before we start the presentation group assignments, I will briefly summarize the speaker materials that we have joined since just day until Friday. Yeah. In the first day, we have Professor Pakorn Opa-Prakasit from Thailand, and also from Himawan from Universitas Gadjah Mada Indonesia, where both of these speakers have talked about the circular economy. As Prof. Himawan said, that circular economy is the open-minded research. So I think we have to take part and take an action to plan the research. And the chemical recycling is one of the promising solution to convert the biodegradable polymers or non-biodegradable polymers into polyester derivative that can be used many times and in several applications that can be used. So it can save our environment from the many pollutant, I think. And the next day, we have 3 women scientists, yeah, and they have talked about innovation in food technology. We have Dr. Widi and also Dr. Ningrum, who have talks related to functional food, and from these talks we got new perspective on several types of functional foods, such as edible flours, and then mixed tempeh from several legumes, and also gelatin, which can be a choice food that are rich of nutrients for the future. And besides, we also gain knowledge related to the novel antibacterials from Dr. Carla, which can improve our food safety from bacterial contaminant, and also we can have food that has a long shelf life, so we can get the more safety food in the future. And in the third day, we have Dr. Dede from BRIN, yeah, who has talked about biomaterials, yeah, from fungi. So from these talks, we know that fungi is not about the food or the disease, but from fungi, we can develop many products that can do the industry, such as pulp industry, novel medicine, and from enzyme industry, and also from for biofuels. And the second speakers, we have Prof. Sung Yoon Lee from KNU South Korea, and we have learned so many things related to water treatments. yeah, especially how to do water treatment through desalination and how to reduce the pollutant through the membranes. And I think this knowledge is very useful, especially to overcome to clean water for the coastal areas. Yeah, I think. And the last day, okay, the special day, we have 4 speakers actually, and it's a very hectic day, I think. And we have from the reducing carbon emission, we have Prof. Rizalman and also Prof. Wawan, who have talked many things related to greenhouse gas, GHG emission. And this is the interesting issue. And I think all of the people in the earth right now facing this problem, yeah. And from these talks, we got many insights, especially related to the side of GHG emission. And for me personally, it's a little bit open my eyes, and so I know that how, especially environmental people, got the dilemma, yeah, dilemma to solve this problem of the climate change, because we can see from, we should know from the economic side and also from the environmental side. And the last 2 speakers talk about renewable and clean energy, from Dr. Grandprix from ITB Indonesia, and also Prof. Paul Loksho from Malaysia. And both of them talks related to the materials that can use to produce the clean energy, such as zeolite and also microalgae. All right, that was all the material from our speakers. And now we should move to the next special agenda. And honestly, I can wait for this session, because we will have presentation from all of you. And I have checked the posters, and I think Butri, could you share the slide? We already have 10 best posters, yeah, based on the like and also the comments. Okay, actually we have around 15 posters, so I think all of this poster is good, yeah, is yeah, it's very interesting. I don't know, I maybe I can make the beautiful poster like all of you did. So, but from the like and also comment, we have 10 best, these 10 best posters, yeah. And these posters, from the 1 to the 10, we have we already make a code where the first posters, Kitosan based bioplastic for biodegradable food packaging, is VSS1. Kitosan based biodegradable film for packaging application is VSS2. And water waste treatment effective microorganism VSS3, and biomaterial and biocomposite 3. I think it's a team, yeah, VSS4. Hermetia Illosense as an alternative proteins VSS5, and unlocking Indonesians geothermal potential is VSS6. Renewable and clean energy VSS7. Transforming carbon dioxide to carbon materials VSS8, palm oil and circular economy VSS9, and anti-diabetic jelly VSS10. So all of these posters you should present to the all of participants, and for this for each posters will be presented for 7 minutes, yeah, and then followed by 3 minutes of questions and answers. So for all of other participants, you should take a note, and then you can raise your hand to ask about your friends' posters. Okay, and for the presenter, please make the presentation as attractive as possible. There will be a reward at the end of the event. So please make sure make the presentation is very attractive, yeah. And to determine the order of the group, the committee will spin the wheel. Maybe Bu Vidya or Bu Tri can share the wheel to choose what the who will be present the first. Yeah, we can so make sure your code poster, yeah. We will spin this wheel, and then if it choose VSS 6, so the VSS 6 should present the poster. All right. Any question from the participant maybe before we start the session? Is it clear? Okay, I think it's clear. So without any further ado, we will start to spin the wheel. Maybe Bu Trianisa, we can spin it. Yeah. Yeah. Okay, VSS 8. All right. VSS 8. Okay. From Satria, yeah, the presenting 7 minutes. Okay, Bu Tri, I think it's for the next, maybe we can spin later. Yeah.
Okay, well.
VSS 8, yeah. Okay, who is the team from the VSS 8? What the title? Transforming carbon dioxide to carbon materials. All right. Who is the team? Or please. Transforming carbon dioxide to carbon materials.
I think this is the slide Ibu Amel, ya? Transforming carbon dioxide to carbon materials, right? Okay.
Right. Is there any, okay, from Oais, Reza, Rosita, and Zian. I think Oais can. Who others? Reza. I think there is Oais Khan. Maybe Oais Khan can present your team assignment. Oais. Hello. Or other Reza, Rosita, and Zian. Okay. I think we can move to next group, maybe Bu Tri, yeah. So the VSS 8 maybe will be the last to present their topics. Is it okay?
Yeah, I think we can choose another group, Bu Amel.
Okay. Yeah. And for the VSS 8, maybe we will save for the last. Yeah. Bu Tri, we can spin the wheel again. Hello, Putri. Are you there? You can spin to choose other group.
Can you see my Chrome, Ibu Amel?
No. Maybe you can share again.
Okay, how about now?
Yeah, still process. Yeah, okay.
So,
Okay.
can I start?
Yeah.
Okay.
Yeah, VSS. Okay, VSS 10. All right. The members of the VSS 10. What the title of the poster? Anti-diabetic jelly. So it's a very interesting. I really want to know about the jelly, yeah. So could we can still snacking like jelly, the sweet one, to prevent our the members. Please present your poster right now. Don't be shy, yeah, everyone. All of hello. Is it my connection okay?
It's okay now.
Not only the participant. Yeah. Okay. Not only me learn how to about the SDGs, yeah, and also about the language. Don't be shy because I also try to learn, yeah, how to speak English with others. So please present the poster. The who is the members media or jelly, anti-diabetic jelly. So we have Dita, Sinta, and Louis and Roya. Dita, Sinta, Lucy, and Roya. Okay. Dita. Dita, Royan. I think I don't find the name in the participant. Yeah. All right. It's already 2 posters, but there is still no members want to present. So I think I will give the idea that who want to present first the poster, you can raise hand. Yeah. Maybe it will be nice if you want to. Okay. We have Irene Sofianti. Nice. What group, Irene? Hello, Irene.
Hello, good morning, ma'am. I'm from
Good
Group
morning.
1.
Group 1. All right. VSS 1, yeah.
No, VSS 3. I mean.
Oh, VSS 3. What is that? What the title, Irene?
Water waste treatment by effective microorganism.
Okay.
Technology.
All right. Sip. Okay. Wow, very nice. Thank you, Irene, to volunteering, yeah. Volunteer to present. All right.
Okay.
Okay. please, the time is yours. For other participants, here our first presenter from the VSS3, water waste treatment by effective microorganism. It includes 4 countries. Yeah, it's very nice. Okay, the time is yours.
Okay, thank you, Bu. Assalamualaikum warahmatullahi wabarakatuh. Hello, everyone. Good morning. We are from Group 1. Would like to present the topic about water waste treatment by effective microorganism or EM technology. With our concerned fact that around 1.2 billion populations do not have access to safe drinking water. According to UNICEF 2022, 70% of the 20,000 household drinking water sources are contaminated by fecal waste and spread diarrhea disease, which is the main factor cause of death in children under 5 years. And a quarter of all children under 5 in Indonesia suffer from diarrhea. It's very heartbreaking news. And let's discover to Vietnam. According to UNICEF, in recent years, Vietnam's government has put a lot of efforts to implement the water supply and sanitation programs with remarkable results. But unfortunately, Vietnam still have challenge in lack access to clean water remains a major challenge affecting children in rural area. It causes malnutrition related to poor water and sanitation. And according to National Nutrition Survey 2019, the proportion of children under 5 years of age who are stunted in the whole country is 19.6%. And this rate reaches over 30% in some ethnic populations. And diarrhea ranks is 7th in the national burden of disease, and one of the main reasons is the lack of access to clean water for eating, drinking. Natural Resources and Environment and Health Ministries claims that 9,000 people die every year due to poor sanitation and water quality, and nearly 250,000 people are hospitalized because acute diarrhea caused by contaminated domestic water, and some 200,000 have cancer linked to water pollution. And let's discover to Pakistan. According to Daud and others in 2017, about 20% of the whole population of Pakistan has access to safe drinking water, and only 20%, and the remaining 80% of population is forced to use unsafe drinking water due to scarcity of safe and healthy drinking water sources. And we have the same challenge and condition in general. And let's go to the topic. What is wastewater? And wastewater is the polluted form of water that generates from rainwater runoff and human activities in daily basis from domestic and industrial sources across the globe. The wastewater compositions typically divided into 99.9% water and 0.1% suspended solids. 0.1% suspended solids consists of 70% organic material such as carbohydrates and sediments, and the other 30% inorganic material such as sediments, metal, and salt. Also, the source of wastewater are from industrial waste such as pharmaceutical, food, paper and pulp industries, and then from agricultural waste, urban runoff, hospital discharge, municipal waste, domestic waste, and personal care products that always develop as time goes by. And our team discovered the best solution for this issue that related to 6 SDGs that ensure access to water and sanitation for all by using EM technology that easy to produce and socialize to the community. And recent research on beneficial microorganisms are getting wider in wastewater treatment application and has shown initial success with the recovery of clean energy. And what is effective microorganisms, or EM? And this is an eco-friendly, safe, and organic product developed by Dr. Teruo Higa from Japan. Dr. Higa is best known for his discovery for EM technology. And the funny thing is, this incredible discovery occurred by accident. Dr. Higa accidentally spilled microorganisms. And a few days later, he noticed that the shrubs had grown extremely well in 1960s. And after many trials and errors, Dr. Higa discovered an optimal mix in 1980s that promoted healthy plant growth for agricultural. And EM basically is a liquid product and consisting of a variety of coexisting aerobic and anaerobic effective or beneficial microorganisms and non-pathogenic microorganisms. And EM has some beneficial microorganisms such as 5 families, 10 general, and more than 80 type of aerobic and anaerobic microbes. There are main species involved in EM are lactic acid, bacteria, photosynthesis bacteria, fungi, actinomycetes, and yeast. The use of EM to treat wastewater played role biological treatment. Bacteria and other microorganisms will remove pollutants from water by digesting them, and thereby getting rid of impurities in the water. The bacteria consume and digest the organic material in wastewater through their metabolism. The organic material is changed into cellular mass, which is no longer in solution, but is settled at the bottom of a settled tank or container. They make up EM and produce a substance that survives in a mixture of EM culture in a brown solution containing 100 million active microorganisms per milliliter and under 3.5 of pH. The microorganisms can survive in unfavorable environment and effectively competing with pathogenic and destructive microorganisms, then replacing them. And it has been demonstrated that EM produces substances that play the role of antioxidants and inhibit harmful microbial species, as well as enhance the production of organisms, and that are beneficial to animals in aquatic. And this substance detoxify harmful substances, and EM has beneficial organisms that decompose the organic matter into methane, carbon dioxide, or other useful substances for growth and reproduction. And therefore, EM is very important in the treatment of wastewater as well as improvement of the quality of water. And the product for the wastewater treatment is EM mud balls that consists of inoculating dried soil and EM bokashi with activated EM1. And because of their density, they will sink to the bottom of rivers and oceans, decomposing the sludge gradually. It is water system and has been adopted by over 100 countries across the globe for commercial use and environmental management. And there are some advantages of using EM, like deodorizing waste, controlling eutrophication and wastewater, having natural fermentation process without chemical engineer or genetically synthesized, and being eco-friendly and playing the actual role of protecting the environment. And this is the key advantages to solve our problem, preventing the growth of pathogenic bacteria. And also it has some application in this table. There are type of wastewater sources, like sample from the sewage pipe with the parameter heavy metals, with batch reactor, and then municipal wastewater with the parameter COD and total nitrogen, with the sequencing batch reactor, and beet sugar wastewater with the parameter COD, BOD, and TDS with batch reactor, domestic sewage with the parameter alkalinity TDS, BOD, COD with the batch reactor, and raw BOD, COD, TDS, and TSS with the batch reactor, primary settled municipal wastewater, COD, POD, TSS, ammonia, and total phosphorus parameter with anaerobic sequencing batch reactor, and scientific wastewater with heavy metal parameter with absorption process, and so many applications that already studied. And sorry, can I share screen about the short video explanation?
Yes.
Okay.
Yes, please, Erin. Dear all other participants, if you have question, you can type the question in the chat box, or you can raise your hand so you can ask directly to the VSS3 teams. Okay.
Imagine a special lush trees for your siesta, crystal clear water to swim in, clean surroundings, a beautiful spot where you can be one with nature. Wouldn't it be nice if that place actually existed? Unfortunately, with urbanization comes pollution, the death of aquatic plants and animals, less fish to catch, and more flooding. Our rivers need help. Good thing we have Super Mud Ball! This mud ball contains numerous effective microorganisms that help clean up the water. The most dominant ones are lactic acid bacteria, photosynthetic bacteria, and yeast. Here's how. In the environment, there are harmful, beneficial, and neutral indigenous microbes. Harmful and beneficial indigenous microbes like to eat sludge. If there's more pollution, harmful microbes increase, and the neutral microbes turn harmful as well. Effective microorganisms in mud balls are EM, enhances and increases the beneficial microbes, which turn neutral microbes into beneficial ones, and eventually outnumber the harmful microbes. This is where the lactic acid bacteria comes in. They help so the beneficial microbes can continue eating the sludge. Meanwhile, photosynthetic bacteria in mud balls reduce the water's bad odor. And lastly, mud balls contain yeast, which produce hormones and enzymes that help aquatic plants and animals grow. With continuous use, these mud balls help clean up our river. And guess what? The Super Mud Ball wants you to be a cleaner of the earth. Help out, support, and be involved in this project. Contact Earth Venture to learn how. Together, we can make our community a cleaner and greener place.
Okay, thank you. That's all. Thank you for your attention. Sorry for the mistakes. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. All right, thank you, Irin. So maybe you can call all of your team members. Irin from the Vietnam, yeah. And then.
Okay, our member consists Yeda Safina Ali from Pakistan.
Okay.
Hello, Safina Ali. Can you hear me?
Hello, Safina Ali. Are you join the meeting? Okay, and then? Yes, I can hear. All right.
Okay.
And then?
Fataria Zakaria.
From
from Malaysia. I'm from Malaysia.
Okay. Okay, Fataria Zakaria. And then?
Nguyen Pho Hoang An. Sorry for the mistake pronunciation. Hello,
Okay.
Hoang An.
Okay, Hoang An. From Vietnam, yeah.
Yeah.
All right. And?
Zidan Akila Rashid.
Okay.
And then Aferous Raihan, Siti Nurmila, and Irina Sofianti.
Yeah. All right. Thank you, Irene. So it's a very interesting, yeah, very interesting and such a great job, yeah, great poster. I read the poster and all of you used a many station actually. So it's a very nice poster. And maybe thank you very much for the Irene and also VSS 3 members have made the great poster actually about the effective microorganism for water waste treatment. All right. For the other members, for the other participants, maybe you want to ask a question to the VSS3 groups. There are Irene, Fataria, and then Hoang An, yeah, Zidan. Maybe some of you want to ask about the effective microorganism. Please ask a question. Yeah. I hope all of you can active participating this session. So it will be nice if we can have a discuss. Okay, from Safina. Yeah. Maybe I would like to ask to the VSS3 groups. There is the effective microorganism. So it's already commercial, right? Yeah. For the effective microorganism, it's already commercial and yes, it is commercial in many countries. Okay. Actually, in Indonesia, yeah, maybe Irene from Indonesia, right? Or not? Yeah, yeah. We have a Ciliwung River. Yeah, Ciliwung, right? If I'm not mistaken, that the river is a very contain many pollutant. Yeah. Is it possible the effective microorganism can solve that problem? Maybe from Irene or the members. Actually, the river is a very so many people know about this river because of this river is a very so many pollutant in there. I don't know. Is it possible to use effective microorganism to solve that problem? Yeah. I just curious, yeah. Could you open your video, mic, audio? So, Safina or Irene, could you please unmute?
Hello. Maybe I can answer the question. Can you hear me?
Okay.
Can you hear me?
Yeah, excellent. Please.
Yeah, yeah, excellent.
Okay. As presented just now, the effective microorganism, I think possible to be used at your country. Which river that you see just now? Because there are many research from the what we present from the poster that being used effective microorganism to wastewater, various wastewater, such as wastewater from hospital or from industry or whatever. Okay. I hope it answered your question.
Okay, thank you, Fataria. So is there any specific dose, for some liters of waters maybe to use the effective microorganism? Is there any specific dose or concentration?
From my reading, from my best of knowledge, I know that they are being used as a solvent or as a liquid, or they made mud ball or slush ball to be placed at the river or the wastewater. For the dose, I'm not sure. So the application is using the liquid or mud ball, or as we can see in the video right now, or slush ball, like that.
Okay. Basically, we can use the EM through the liquid or solid, but the concentration maybe we should read more about the research, right? Okay, thank you, Fataria. All right, for the VSS3 groups, there is a question from Zahrina. Is effective microorganism principle similar to mycoleca, LECA, that using immobilization? I get the question. Is EM have similar principle to mycoleca that using immobilization for the?
I think the principle is similar.
Similar. Okay.
Little use like ball, like just presented from our lecture, last lecture, microleca. I think that they are similar application principle.
All right. So the EM principle similar to the mycoleca, Fataria.
Maybe. For your information, we are from other field. Like me, I'm from food technology. So, but we are together in we try our best to understand about this wastewater treatment from the paper and from our reading. Actually, we from the group a different background from what we are assigned to do the topic.
All right. Okay. It's okay, Fataria. I'm sorry.
It's okay. We are learning. We also learning.
Okay. Thank you, Fataria. Yeah. For Zahrina, is it clear, or do you want to asking more the question?
Yes, it's clear. Thank you, Fataria.
Okay, thank you, Zahrina. All right. Thank you very much for the VSS3 groups and also the question from Zahrina. I think we can move to the next group, I would like to invite the participant who want to present the projects. Please raise your hand. Okay, thank you very much, Huang An. It's a very nice poster and very nice topic. Yeah. Okay, we have Priya here. Hello, Priya.
Yes, hello.
Hi.
Hello, hi.
What your group?
My group is VSS4. Can I ask help from the committee members to share the poster instead? Because I think my group members are not here.
Of course, of course, of course.
Thank
So,
you.
your title, your poster title is biomaterial,
Yes.
biomaterial and biocide 3, yeah. Okay.
Yes.
Maybe the committee, Bu Vidi or Bu, or from me. Oh,
Is it your poster, Priya? No.
No, not this one. Yes, that's the one.
This one?
Yes.
Okay.
Thank you.
I will download first.
Okay. From for your members from Malaysia, or is there any from Indonesia or other country, Priya?
Yeah, they are from other countries as well. I saw them. They are from Indonesia, Philippines, and just now Nina from that the moderator has interviewed actually from my group as well.
Okay, nice. So, is the poster? Yeah. All right. Okay. So the members is Priya, Nina, Anis, Dandi, Khairul, and Mansur Ahmad. Okay. Priya, please start your presentation about the project. Time is yours.
Okay, thank you. Selamat pagi and a very good day to everyone who are attending this virtual summer school 2022. So my name is Pradarshini from Malaysia, and I'm going to represent my group to present about what is biomaterial and biocomposite, especially using chitosan as an example for the biomaterial and biocomposite. So without any further ado, let's look what is biomaterial and biocomposite. So biomaterial is any material which is natural or man-made, which is made compatible with living tissues and performs, aids, or replaces a natural function. It is used and adapted for medical application. Meanwhile, a biocomposite is a material in which at least one of the raw materials utilized is obtained through natural sources. Hence, that's why our group members have chosen chitosan as a precursor for the biomaterial. So what is chitosan? Chitosan is a deacylated derivative of chitin, which can be found in the shell of crustaceans. So what is crustaceans? Crustaceans are basically any living organisms that has exoskeletons, of which we know easily as shells, such as prawns, crabs, shellfishes. Even insects are also known as crustaceans. So this chitosan is linearly consisting of D-glucosamine and N-acetyl D-glucosamine units, which are linked by beta-1,4 glycosidic bonds. So below the so in the poster, our group have presented the molecular structure of chitosan as well. So how this chitosan is made? So this chitosan is produced commercially by the deacetylation of chitin. So as I mentioned earlier, this chitin is the structural element that can be found in the exoskeleton of crustaceans and also the cell walls of fungi. So on average, the molecular weight of the commercially produced chitosan is almost 3,800 and 20,000 daltons. A common method of obtaining chitosan is the deacetylation of chitin using sodium hydroxide in excess as a reagent and water as a solvent. So to make it short, actually, basically how to make chitosan is that we obtain chitin from the crustaceans, then it undergoes a series of deacetylation with suitable reagents and solvents. A chitosan could be obtained. So besides that, so that's all how a chitosan is made. So let's look at the properties of chitosan. So chitosan is biocompatible, biodegradable, non-toxic. Besides, it also has a remarkable affinity towards protein, and it is able to be functionalized and it is renewable and abundant as well. So the main reason why we have chosen chitosan as the topic for our biomaterial is that chitosan can be a very good source and a replacement for the plastic. Chitosan, as I mentioned earlier, chitosan is biodegradable, and chitosan can be also obtained through the food wastes, which correlates to the Sustainable Development Goals, especially number 12, responsible consumption and production. By utilizing and understanding the full properties of chitosan, it can totally replace the undegradable plastic usage. This is because millions of animals are killed by plastics every year, from birds to fish and other marine organisms as well. Besides that, nearly 700 species, including the endangered ones, are also known to be affected by plastics. Besides that, there are also pollution going around, which is caused by the accumulation of the plastic as well. So we really hope that one day this the plastic packaging film, which is made of chitosan, could be really developed and be commercialized and widely utilized in around the country and around the world as well. So here's a little fun fact from our group. So when we are doing the research about chitosan, we found that in a recent study in Nankai University, Tianjin, China, a chitosan film which has antibacterial, antioxidant, and water degradable properties had been developed from American cockroach. So they are also so in the research paper, they are also shown that this chitosan-based food packaging film also has an oxidation rate until 15 days and 48 hours as well. So such results shows that this chitosan-based food packaging film could really have its properties to really keep the besides keeping the shelf life of the food and also water degradable as well. So this huge finding could really prevent the accumulation in the environment. So we really hope that one day this chitosan-based food packaging film, or even any plastic bag, any plastic packaging films, could really be widely utilized and it can be commercialized as well. So that's all from our group. Thank you. And besides that, I also would like to grab this opportunity to thank my group members and also the committee members. For my group members, I would like to thank them for cooperating with me to do the poster, and for the committee members for organizing such a wonderful summer school event, which I really enjoyed a lot. Thank you.
Thank you very much, Priya. It's a nice presentation, yeah, from the chitosan, yeah. So we now we learn about the chitosan as a biomaterials, right? So Priya got the love from Dr. Fitri. Actually, Dr. Fitri is a chitosan expert, yeah. So Dr. Fitri has many research related to chitosan, yeah, using chitosan as materials. Okay. Any other question? Okay. Thank you, Safina. Priya, there is a question from Safina Ali. Is it commercialized? If yes, is it commercialized or not? Maybe the food packaging, I think, yeah, Safina, or chitosan.
Actually, I would like to say I'm not an expert as well, because it's different from my field. But from what I know so far, I think it haven't been commercialized yet, because basically the bioplastics that we have found in the market is so far it's about starch-based bioplastic. It is not yet more chitosan-based yet. So we hope that one day we could really lower the cost of the production of chitosan, in the production of chitosan-based plastic packaging, and we can commercialize the chitosan-based packaging film. So I think so far it is, from my knowledge, so far it's not yet commercialized and widely used. Thank you.
But it's nice. And then the next, the following question: if yes, if it's commercialized, then what's the cost compared to the normal plastic-based packaging? Maybe Priya can predict, is it more expensive than plastic-based packaging, or because we have many crustaceans as a natural products or waste, so it's a very cheap maybe? How about
Yeah, I think
what do you
if
think?
we really want to lower the cost of the cost of the production of the chitosan based plastic film, I think we can utilize from the food waste, especially from the food waste, because I think from there we could really lower the cost of obtaining the shells. I think because maybe the production and the isolation of the chitin could be expensive, but we can reduce the cost from the obtaining from the obtain of the shellfishes from the the crustaceans. So I think yeah, we can reduce the cost from there by utilizing our resources such from food waste. And we also learn about valorization, so maybe I think that could like be applied there.
Yeah, good, nice. Yeah, maybe the isolation we got the most we will expend more cost, but from the source, because of chitosan is a natural, a natural source, I think it's can lower the cost. Okay, nice, Priya, for the answer. Okay, we have a second question from Zahrina. I heard that is it your friend? Okay. Yeah, I heard that the chitosan plastic can be degraded by water. Is it safe to store it in humid condition? Okay, maybe the Zarina worry that the food packaging will be break. Yeah, what do you think, Priya?
So based from my studying and the journal that I presented, the fact that I read, it says that the chitosan, we need to have the suitable solvent to increase its antioxidant properties, or without a good solvent or good reagent, it will be easily, how to say, easily oxidized. So we really need to have a good solvent to increase its antioxidant properties to enable it to be safe to store in the humid condition and work as a normal plastic as well. So I think we need to have a suitable solvent, I think.
Okay, nice. Thank you. Maybe from the bioactivities side, yeah. We need the best solution solvents. But I think for the physical properties, maybe we should give some additive, maybe, yeah, like other materials that can improve the physical properties of the chitosan, yeah. Okay, thank you, Priya.
Thank you.
Yeah, thank you, Zarina, for the question, and thank you, Priya, for the nice answers. I think all of us learned many about the polarization also, yeah, from our speakers, and from from the chitosan as a biomaterial. I think it's very promising, yeah, material for our future. Plastic, maybe food packaging, yeah, for this for these papers. Okay, thank you very much, Priya, for the excellent explanation, and also for the nice poster. There is crustaceans there. It's very cute. Okay.
Amel, just my short comment. Priya,
Okay.
I do love your presentations, and thank you for sharing knowledge, yeah, to us. Just a comment to additional comment to Zahrina questions. Actually, chitosan itself has hydrophilic nature, right? With the special functionalities such as OH and amine groups. So if the question is it safe to storage in the humid conditions, in my opinion, it depends on your purpose of applications. Yeah, if we want to use chitosan-based material as the the storage materials to keep humidity, maybe it would be best, because it would be easy to attract water molecule. Yeah, and you can keep the humidity. But for other purposes, if we would like, for example, for the food packaging, if we would like to protect the food quality from the humidity and so on, maybe we need to modify the Kaitosan itself, yeah, by composite system, for example, to reduce the hydrophilicity. Then we can keep the food in the proper condition. So we can, yeah, as Priya said, we can tailoring the properties based on the target application that we would like to propose. Yeah, and yes, it's absolutely agree that Kaitosan is cheap. If you're still questioning about the cost for synthesizing Kaitosan from cockroach or or seafood waste, yeah, something, in my opinion, is still even cheaper, yeah, compared to other processes, because we only need normal acid and base. That's all, yeah, to obtain Kaitosan. So yeah, this is a good way. If we still remember the lecture from Prof. Pakor regarding to the circular economy, actually we can do, yeah, a kind of circular economy from from the marine waste, such as how to say crustacean cell, yeah, how to process it, and then it would generate the economic or income by the end of the process. So that's maybe my additional comment. Thank you.
Thank you very much, Bu Fitri. So because Bu Fitri already did many research related to the Kitosan, so it's very nice. We have other insights from Dr. Fitri. Thank you, Bu. Thank you very much, Bu Fitri. All right. Okay. Thank you very much, Priya. Maybe we can move to the next group. Okay, Satria Rizky Ashar raised hand. Hello, Satria.
Hello, Ibu. I'm from VSS1.
Okay,
We
nice.
start the presentation.
Yeah, okay, please, Satria, you can start your presentation. VSS1, yeah. The title is Kitosan-based bioplastic for biodegradable food packaging. Is it right, Satria?
Yes, biodegradable.
Okay. Yes, please share your poster or PPT or your materials so you can start your presentation.
Okay, is anyone can share screen here?
Yeah. Who want to share the poster from committee or from Satria? Zarina?
Yes, ma'am, but I couldn't find the option here.
Share screen?
Yes, or maybe from the committee can help us, maybe.
Okay.
Okay, I will help you.
While we are waiting, Bu Tri to...
Okay, is it your poster?
No, ma'am.
I think no.
Another one, I think, Bu Tri.
Another one, yeah.
Check first. Kitosan.
There, circular economy 1, ma'am.
Yeah, okay.
Yeah.
That's the left one. Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay. Good morning for all. I'm from VSS1, which with our groups, all our members, Miss Najweni Muiz, Muhammad Rizky Fadil Pratama, Adrian Harold, Muhammad Alia, Zarhina Alfia, Camila, Erika Agustina, and me, Satria Rizky Azhar. I'm from a chemistry student batch 2021 in Universitas Pendidikan Indonesia, Faculty of Mathematics and Science Education. Our topic is about chitosan-based bioplastic for biodegradable and food packaging. Okay, we start right now. It's about introduction. Okay, from this point, we can see that most of the materials used in the packaging industry are oil-based polymer materials that cannot be decomposed naturally, such as the product like plastic. We know that plastic is very difficult to decompose naturally, and also we have to the further development of renewable packaging or green packaging has a potential to reduce the negative environmental impact of synthetic packaging through the use of biodegradable materials such as biopolymers, chitosan, cellulose, and starch. But the other one, we talk about the chitosan. It's from a shrimp with the deproteination and demineralization become a chitin, and we have to the acetylation to make a chitosan. What is it? Chitosan is a natural, non-toxic, and high molecular weight polymer that is biodegradable. That's the reason why we choose the chitosan for the biodegradable polymers. Like flame fiber, chitosan has a positive ionic charge amino group, as you can see in the structure of the molecule in chitosan, which there is a amino, which gives it the ability to chemically bind the fats, lipids, cholesterol, metal ions, proteins, and negatively charged macromolecules. Chitosan has gained increasing commercial interest as a raw material due to its excellent properties, including biocompatibility, biodegradability, absorption, and the ability to be spread as thin film and chelated with metal ions. As a result, chitosan is widely used in various industries such as pharmaceuticals, biochemistry, biotechnology, cosmetic, and food packaging. Okay, the next one for our members. The time is yours. Thank you.
Okay. Okay, the next topic is about the fabrication strategies for preparing chitosan-based films. From the image, we can see there are 4 types of chitosan-based film preparation methods. There are solution casting, layer by layer assembly, extrusion, and coating or spraying. The most widely used method is solution casting because this method is the easiest one. However, this method is generally carried out on a laboratory scale. So the steps in solution casting is, firstly, we have to dissolve the chitosan in weak acid solution. After that, after the chitosan is completely dissolved, the solution can be directly molded or added with functional materials or fillers such as antimicrobials, antioxidant, or plasticizers. And then the solution in the mold evaporates at a certain temperature and time. After all the solvent has evaporated completely, the thin layer can be peeled off from the mold. The second method is layer by layer assembly. The technique is commonly used for multi-component films that do not require sophisticated instruments, such as the solution casting method. However, this method requires a relatively longer time because of the gradual drying process at a certain temperature. When the solution as the first component has dried, it is continued by adding the solution as the second component until it is dry, and so on, until a multi-layer film is formed. The third method is extrusion, that is widely used for production of conventional commercial plastic packaging films. Extrusion is often preferred over the solution casting method due to faster processing times and lower energy consumption. The extrusion process often provides films with acceptable mechanical properties and good thermal stability. And the last method is coating or spraying. They are usually used for fresh foods such as fruit, vegetables, meat, fish, etc. to extend their shelf life. This technique has the advantage of being easy to perform and doesn't require sophisticated tools. However, it needs to be a certain preparation for the target food to be coated. The usual steps are: first, formulation of raw materials using cytosine and fillers in appropriate properties. Second, disinfection of food samples using sodium hypochlorite solution. Third is spreading the cytosine-based composite solution into the food to form a uniform layer using a sterile spreader. And the last is drying under certain condition. While spraying technique involves similar steps as coating technique, except that the spraying is carried out using a compressed air assisted sprayer. Okay, the next topic is from another member.
Thank you, Jarina. The topic about the example of cytosine-based film or bioplastic. There are 4 papers we took here. The first paper is bioplastic from chitosan and additive zinc oxide nanoparticle loaded gallic acid. The properties of films, the result is the first is tensile strength. The bioplastic is 54.6 83 and megapascal, and the elongation at the brick is 52.16%, and water solubility is 16.34%, and the last properties of film is water vapor permeability is 1.176 centimeter per centimeter quadrat second Pascal. And the antimicrobial activities from the bioplastic is Bacillus subtilis and E. coli. And the type of food can be used for fruit. And the second paper, bioplastic from cytosan and polyurethane and additive zinc oxide nanoparticle. The result of properties of films is there, and antibacterial activity for E. coli and S. aureus. And the fourth type of food is carrot. And the third paper is bioplastic from chitosan and PPA, and additive zinc oxide nanoparticle and anthocyanins. There are Rossell's calyx and purple potato powder, and this is properties of films and antibacterial activities in E. coli and S. aureus too. The type of food is same. And the last paper is bioplastic from cytosan and cellulose nanocrystal. The properties of film is there, and antibacterial activities for C. albicans, Pseudomonas, and Enterobacteriaceae. And the type of food is for chicken meat. That's all the papers we can review the poster. And the conclusion will be presented by Satria.
Okay, thank you. Okay, I will tell about the conclusion about this presentation. These refers some recent studies on the fabrication strategies for preparing chitosan-based bioplastic and their application in antibacterial food packaging. As we know about the plastic, and the problem is about with the plastic or oil-based polymer is it cannot be decomposed. So the addition of additive, organic or inorganic compound at appropriate concentration can improve the overall mechanical, barrier, and antimicrobial properties of the chitosan-based films. This research relates to consumption and production, which are at the core of the global economy. SCP encompass the objective of a systematic decoupling of economic growth from escalating resource use and environmental degradation in order to do more with less. Thank you very much. We are sorry for the mistakes, so we close our presentation and who want to ask the question to us, just raise hand or type the message in the Zoom. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
wabarakatuh. All right, thank you very much for the VSS1 members. I think it's a very solid team, yeah. So the presenter not just only one. There are Satria, and then Lisna, and then Zahrina. It's a very great presentation. Yeah, VSS1. All right. Thank you very much. All right, for all of other participants, if you have any question related to the VSS1 poster, yeah, chitosan-based bioplastic for biodegradable food packaging. So basically, it's a similar with the PRIA groups, yeah, but it's already specific to the bioplastic for food packaging. So I hope other participants could raise hand or type your question in the Zoom chat. Okay. Is there any question?
Is any question?
Yeah. All right. There is no question?
Maybe there's no question. Yeah, so maybe we have to close the meeting and not meeting, but
no.
presentation.
No, maybe I want to ask questions.
Okay, it's all right. Just a question.
Yeah. Okay. In your poster, actually you are reviewing 4 papers, right? There is chitosan, and then I think basically is composite, yeah, that contain chitosan. And for the application, there is several type of foods. There are fruits, carrots, shrimps, and also chicken meat. I would like to ask about what the fabrication strategies for all of this review to package all of these type of foods. Maybe in this fruit, the researchers using coating, or maybe from for the chicken meat, they are using solution cast, or which one the method that they use for the package.
Thank you the question, Ibu. May I answer your question?
Yes, please, listener.
Yeah. We just put the for paper in here yet. And we read the fabrication strategies for the bioplastic from for fruit, carrot, shrimp, and chicken meat. The strategies use coating and spraying because because the bioplastic need to contact the food. Yes.
Need to contact the food directly. Yeah.
Yes. Yes.
So all of the papers using spray method, listener?
I think for the fruit, carrot, and shrimp, but for chicken meat, I forget. I'm sorry.
Okay, it's okay.
Yeah.
But so I'm curious. One question more, right? Okay, is it okay? So if the researchers using spraying method, yeah. So it's directly contact to the food materials, right? So is it is it edible or not?
Yes. Because here from the coating and spraying just for application, but in the characterization such as biodegradable and so on, they have strategies, fabrication strategies. Yes, solution casting because if the film or bioplastic have contact directly with food, cannot use for characterization.
So it means it's not
just for characterization of biofilm. They use fabrication strategies is for solution casting because it is very easy.
Okay, so for the characterization, they're using solution case or extrusion maybe, but for the application to the food, they're using spraying, right?
Or cutting, yes.
Yeah, okay. But for the chitosan-based bioplastic, is it edible or not? We can eat it or not? Edible coating or not?
I don't know about it.
We should remove from the food.
maybe if in the ingredient of bioplastic is we can eat. Maybe it's edible film.
Okay.
Yeah, Bu Fitri. Please help me.
That's right, listener. So according to the edible packaging, especially for the food. Yes, we can create it, but of course we have to consider the precursors, yeah, for the how to say plasticizing agent usually Bu Amel. So for special purposes like food edible packaging, we couldn't mix chitosan with the polymer that has other polymers, I mean, that has, for example, toxic properties and so on. So in most cases, chitosan can be mixed with glycerin or glycerol, yeah, or other biopolymers. Because chitosan itself, in my best experiences in the laboratory, we couldn't make the film easy only by chitosan, but we have to mix with other materials. So the plasticizer agent, yeah, it will be required, especially for preparing a kind of the coating, yeah, a kind of films and so on. If we mix the chitosan with other polymers, yes, we can do, but maybe the purpose not for the edible one. For example, if we mix with, how to say, yeah, many PP or PPA, yeah, or something, yeah, it would be also dangerous. For the plastic bag, maybe no problem, but for edible food packaging, yeah, we have to be careful, and we need to consider the how to say the mixture compounds, yeah, that will be mixed with the chitosan.
Thank you, Bu Fitri.
Thank you, Ibu Fitri and Ibu
Okay,
Amel.
there is Aslan, raise hand. Do you want to ask question, Aslan?
Yes, ma'am.
Okay, please.
My question is, how long does it take for bioplastic from chitosan to be decomposed in the soil and in water?
All right, next question, please. KSS1.
Yeah.
Okay,
Thank you,
please,
Aslan.
Lisna.
I think the one of paper and share us for the information about biodegradable in soil. Yes, in 1 month and 6. I'm sorry. 10 until 30 days for biodegradable in soil.
For sure, actually, it depends on the composition, yeah, Lisna, yeah.
Oh, yes, yeah.
The higher chitosan contents on the composite system, yeah, the quicker, yeah, the shorter time for degradation, for the degradability. I've been trying in our research preparing the composite film based on chitosan, for example, and PPA. Yeah, and we investigated the degradability of this composite system in the soil. Yeah, we can start to observe the degradability start from the first week until around 3 weeks. Yeah, but again, we cannot generalize. Yeah, for the all cases, but in my best experiences, it really depend on the compositions of chitosan in the composite system, and also the type of other precursors, yeah, in that film. If the other precursor also has the good biodegradability properties, of course, it will be the synergetic effect by the end as well. But that's very good question, I think.
Yeah, thank you, Bu Fitri, for answer.
Okay. All right. Thank you, Bu Fitri and Lisna, and also Aslan for the very good question. So I think in this session we got many discussion about chitosan. So it's very interesting, yeah, for the future biomaterial, I think. All right. There is another question from other participants.
Okay, another question.
Okay. If there is no question, I think we can end for the VSS 1 group. Thank you very much for the VSS 1, Satria, Lisna, Zahrina, and others for
You're
preparing
welcome.
the great presentation. Yeah, it is the solid team. Yeah, and then for the nice poster also. Okay, thank you very much for the VSS1. Okay, next we will move to the next group. There is one. Is there one to present their poster? You can raise hand. Maybe I want to hear from the innovation food technology, yeah, because we already have from the biomaterial, yeah, and also water treatment, and we don't hear from the innovation food technologies, and also reducing carbon emission. I think reducing carbon emission is also interesting to talk to present, yeah, and also from the circular economy. Okay, is there one to present? We have we have VSS5 that I think related to the innovation of food technology. Yeah. Wait. Hermesia illucens as an alternative proteins. Is there any there is any members from that groups?
Yes, Miss.
Okay, please, Nana, yeah, Nana, please present.
Yes.
Yeah, your group assignment. The title is Hermesia illucens as an alternative proteins. Okay, for the VSS 5, time is yours.
Okay. I'm sorry, can I ask for help to share my screen poster because my friends haven't been there yet, Miss?
Okay, sir. At the moment, VSS. Yeah, I will share it. Do you see my PPT?
Yes, Miss.
Okay.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Thank you for the opportunity, Miss. So today I will present my group poster about innovation in food technology, where the topic is Hermetia illucens for alternative protein. So what is Hermetia illucens? Hermetia illucens, or the black soldiers fly, is a common and widespread fly of the family Stratiomyidae. And why we choose BSF? Because the dry weight of black soldier fly larvae contains up to 50% crude protein, up to 35% lipids, and have an amino acid profile that is similar to that of fish meal. Before now to farm, as we know about life cycle of black soldier fly, let's approximate 45 days. First, eggs for 4 days. Second, larva stage for 18 days. Third, pupae stage for 14 days, and the last is adult stage for 9 days. A good time to harvest BASF maggots is 2 to 3 weeks after the egg hatch. So what are the benefits or application? The first is because a BASF has antimicrobial effects. Even from existing study, BASF can be considered as a substitute for AGP, antibiotic growth promoter. The second, the protein content is quite high, which is around 40 to 50%, and the types of amino acids are quite complex. And the last is the fatty acid in the BASF maggots are medium chain, thus helping to efficiency. So the conclusion is, as a feed source, BASF contain high protein, 40 to 15%. It has been specifically proven that the use of BASF flour in pigs, laying hens, broilers, and quail as an alternative source of protein in animal feed has good prospect. The use of BASF flour is expected to reduce the dependence of farmers on protein from fish meal and soybean meal, which are increasing expensive and limited in availability. Besides being able to maintain and increase livestock production, BASF flour also contains compounds that act as antibiotics and antiviral, so that is term of livestock health. It is also beneficial. Its ability to decompose organic waste as a breeding medium and its high tolerance for climate variance in tropical environments make BASF easy to produce and as mass scale at livestock and industrial level. Thus, the use of BASF as an alternative protein source can reduce production costs in the livestock industry without reducing its quality. So that's all I can present. Sorry if there are any wrong words. Thank you so much, Miss.
All right, thank you very much. Stop share. All right. Thank you, Nana. Yeah.
Yes, Miss.
Please present. Okay. Thank you very much for Nana and the groups from the VSS 5, yeah. The Innovation in Food Technology, Hermesia Illusions for the Alternative Proteins. All right. For the participants, is there any question? Okay, thank you very much. This is very nice presentation. Okay, is there any question? Actually, this is a fly, yeah. Fly,
Yes.
and the maggot for the food. Okay. Okay. There is a question from Bu Fitri. This fly called as laron in bahasa, isn't it?
In bahasa is lalat, Miss.
Lalat, bukan lalat.
Yes.
Lalat.
Lalat hitam.
I see.
Lalat hitam.
I guess it's laron, yeah, because it's quite common to be processed as keripik or as the other, how to say, food.
Other food, yeah. Yeah.
I see.
But what the stage we can consume the Hermesia illusions when in the maggot stage, or when it can when it's in the or black fly. I think yeah. Well,
I think it's
or
from
fly.
I think it's from adult stage, Miss.
Adult stage, yeah. Adult stage. All right. Okay. Is there any question? Or from the group VSS5? Maybe you can give the examples, the food from the black fly. Oh, sorry. In the chat there is a question from Hendra Kustiawan. Okay, thank you, Hendra. It's mean as edible means. How about the food chain effect if we harvest this BSF? Thank you. Okay. From the VSS5, there is question from Hendra. It's mean BSF could be edible. And how about the food chain effect if we harvest this BSF? It mean rantai makanan, ya, for the ecosystem, right, Hendra?
Yes, ma'am. Thank you.
Okay. Yeah. Please, VSS. Yeah, Nana. What do you think?
This was for animal feed, not for food that can be consumed by human.
Oh, so basically this BSF for feed, yeah, not for human food.
Yes, Miss.
Okay. So the second question from the Hendra, how about the food chain effect if we harvest this BSF? Even this is just for the animal, yeah, but if we harvest more, there's an effect for the ecosystem. What do you think? Okay, I already answered. Okay, Fatari. Yeah. Okay. I think maybe for the VSS5, what the group, what the members, Nana? Okay, Nana, please. What do you think?
Okay, jadi so from the journals I read, these flies can be farmed and can be found around a lot. So I think it don't will affect so much.
So basically, it will not affect the ecosystem cycle, maybe, yeah. For the BSF.
Yes.
And another maybe, yeah. That the answer for the Hendra's question. Is there any question, Hendra, or clarification maybe?
Okay, thank you.
Okay, thank you very much. All right. I think it's already 11. I think we should move to the other groups. But before it, I would like to thank you very much for the VSS5 and especially for Nana for presenting the poster. And it's actually a nice topic, yeah. And thank you for the question from Hendra and also Fataria. Okay, we will move to the next. Okay. We'll move to the next group. Yeah. I think from the And VSS 6, is there any members? Unlocking Indonesia's geothermal potential. It's a very specific topic, yeah. Unlocking Indonesia's geothermal potential. There is a group from VSS 6. No? Okay, I think we will move to the next poster, VSS 7. Renewable and clean energy from group 3, yeah. Who want to present the poster? What the theme? Bu Vidya, there is a name for the theme VSS 7.
I think Nafran, if I'm not mistaken.
Oh, Nafran. Okay. Nafran, there is Nafran in this meeting. I think there is no Nafran. All right. Maybe we will move to the next poster. Okay. Transforming carbon dioxide to carbon materials. Okay. Who want to present this poster? Please raise your hand. Okay. 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 From the committee, there is. I think we should move to the VSS 2 because in this meeting there is members of VSS 2. Okay. Can we move to the chitosan-based biodegradable film for packaging application? VSS 2. I think in this meeting there is Arum, one of the member for this group. Hello, Arum.
Hello, good morning.
Good morning. Could you present for your
Sure.
poster?
I will try my best.
Okay. Nice. Thank you, Arum.
Can the committee help me to show the slide, please?
Okay.
The poster and
yeah, sure. Good.
Thank you. So, may I start?
Yeah, please. You can start now.
Just a moment, please. Okay. Okay, good morning to all presenter, to all the committee of VSS OP. It is an honor to have the opportunity to talk about this kind of, let's say this is a paper review. The title, chitosan-based biodegradable film for packaging application. Actually, I have 4 members, which are actively do this poster. However, the 3 of them are not being able to attend the meeting, I guess. Ivani, she told me that she is not feeling well, and then Anissa, she probably do a lab, and then Mbak Putri, she probably do another meeting or anything that she will do. So let me try to present it by myself. So the plastic pollution is having a huge negative impact on our oceans and wildlife health. With the prevalence of high-income countries, they generate more plastic waste per person. And however, it is the management of the plastic waste that will determine the risk of plastic entering the ocean. a poor waste management across many middle and low income countries means that these are the main sources of the global ocean plastic pollution. With the largest pollution, China contributes the highest share with of mismanaged plastic waste, around 28% of the global total, followed by 10% in Indonesia, 6% for both Philippines and Vietnam, and other leading countries, including Thailand with 3.2%, Egypt with 3%, Nigeria 2.7%, and South Africa 2%. So biopolymer packaging material have been devoted to considerable attention as a green alternative to replacing synthetic plastics toward a sustainable environment. And among the biopolymer, active film based on chitosan that have already been discussed by the previous two teams, I guess, which is obtained from the deacetylation of chitin, is a promising candidate with a broad range of application in many fields, such as food, pharmaceutical, agriculture, and cosmetics, directly or indirectly, and due to its biocompatible, non-toxic, biodegradable, and excellent film forming properties. So this study aimed to produce biodegradable composite film based on chitosan obtained from the waste crayfish shells and reinforced with propolis. So they add some propolis inside the ingredient for the biodegradable packaging, food packaging, I mean. Extracts from different ratio, and the produced film are characterized either for the physical chemical, which are color, thickness, optical transmittance, Fourier transform infrared or FTIR spectroscopy, thermogravimetric analysis or TGA, scanning electron microscopy or SEM, and mechanical properties, degradability in nature, and the biological. They also tested for the biological properties, which are antioxidant, antibacterial, antifungi, and anti-mold activity. So the one that presented in this poster is super compact because we only take the first step to the last step. So the last step, which will be directly correlated with the packaging of the biofilm, something like that. But here I will talk a little bit about the characteristic of the biofilm. So they tested with a lot of instruments. The first one is they try to find the polyphenolic compounds profile of the polypropolis of the propolis. I'm sorry. So they evaluated by the LC with DAD sensor, and then ESI-MS, and the chromatogram allowed the identification and quantification of a total of 41 compounds. So this propolis is rich of active compound. And then they also try to find out the chitin content and chitosan yield. The chitosan yield of the complete procedure was recorded as 16%, corresponding to a chitin isolation from dry crayfish shells of 19%, which is, I would conclude it as a huge number or moderate number of chitin from the dry crayfish. And then the chitosan productivity of from the chitin is 83%. And then, so they also do investigation of the thermal properties using TG and DTG analysis. And then they also investigate the mechanical properties. The mechanical behavior of the film was also investigated in order to observe the variation derived from the propolis addition to the film. And then I would say that the chromatographic profile of the propolis extract confirmed its richness with 41 phenolic compound. With increasing extract addition to the chitosan, the thickness of the film increased from 61.7 to 71.7 micrometer, causing a reduction in the light transmission rate, along with a greenish color shift. The interaction between the propolis extract and the chitosan was confirmed by infrared spectroscopy. At the same time that the microstructural integrity of the film was checked on the scanning electron microscopy micrograph, and the finding also showed that addition of the propolis enhanced the film thermal stability, the mechanical properties, example, tensile modulus, yield strength, and stress at break. Besides, it improved the antioxidant and antimicrobial activity as shown on the figure 1. However, overall, the chitosan-based composite films seems to be a promising green alternative to be aside from the petroleum-based synthetic plastic, allowing to extend the shelf life of the food due to their eco-friendly nature. So that's all. Thank you.
All right, thank you very much for the presentation, Arum, yeah? Okay.
Yes.
It's very interesting that you present related again chitosan-based biodegradable for film for packaging application, but it's different than before. It's while the Satria explain about especially for the food packaging, yeah.
Yes.
But in this Arum, it's from the packaging as general, yeah. So there is a question for. Thank you very much, Arum. And there is there any question for the VSS2 group? Chitosan-based biodegradable. Yeah, for packaging. Okay, from Aslan. Please, Aslan.
Yes, ma'am. Thank you. Chitin and chitosan have a similar chemical structure. I'm wondering, can we change chitosan-based biodegradable film to a chitin-based one? Thank you.
So far as I know, if I'm not mistaken, maybe Bu Fitri later can give some more clear answer for this one. But so far as I know, chitin is the raw of the shells from, let's say, crayfish or crabs, something like that, even insect. If I'm not mistaken, the first presenter said, or maybe the second one said from insect as well. But chitosan is morely like, I'm not sure though.
Is it yeah, Arum?
Yes. Can I say that chitosan is the derivation from chitin, something like that?
Yes.
I'm not sure.
Yeah, that's right. That's right, Aru. Sometimes chitosan also can be called as the deacetylations product, yeah, product from chitin.
So chitin
yeah.
is more complex than chitosan, something like that, right?
Yeah, we remove the acetyl
Acetyl.
group, yeah, from chitin by the process that the first group presented, yeah, in this morning. That's why to differentiate the chitin and chitosan, we can compare from certain parameters such as from the acetylation degree. So in case of chitosan compared to chitin, it should demonstrate the high the acetylation degree value that can be determined actually from FTIR spectra.
So for the question that Aslan asked about the switch between chitosan to chitin, I guess it will affect to the properties, whether it is physical, chemical, physic and chemical properties of the food packaging, and then we have to something test to the food whether it works or not. We also have to test it whether it is toxic or non-toxic, and then whether it works for the directly for the biodegradability, the durability, something like that. I guess we have to consider it, but in the paper they didn't discuss about the switch between chitosan to chitin, something like that. That's all. Hopefully it is clear. I'm not sure.
Yeah, that's right. I agree with your answer. So Aslan, yeah, who delivered the question. Yeah, of course, since chitosan, the backbone actually is quite similar, yeah, the backbone structures between chitosans and chitin, but the difference is the number of acetyl group that still remain in the structures. Yeah, in case of chitosan, because it's a product of the acetylations processes from chitin, so the number of the acetyl group will be less compared to chitin. And I'm not sure if Aslan is a chemistry student or not, but if you are the chemistry student, you know the steric effect, yeah. Bu Amel maybe later on can can explain about the I totally agree with the statement from Aru. It would affect the reactivity, yeah. If the reactivity different, of course the physical chemical properties also will be different and so on. Yeah. So that's maybe the point. Yeah. Again, I've been used actually, Aru, the chitin itself, but not for preparing film. At the time, I use it as the adsorbent, yeah, to remove the heavy metals. It is quite powerful. I even combine the chitin with humic acid. So I try to prepare the composite adsorbent that having huge oxygenated functionality groups, yeah, that can be attractive for for absorbing the heavy metal ions. For example, at the time I apply silver ions, and then even cadmium and some other heavy metals ion, yeah, that potentially available in the wastewater.
As for me, I think I have a research, like a simple research during my bachelor degree. I code the chitosan to the film, but we use it for the biodegradability test. So we use it as we plan to use it as a seedling tray, something like that. So it is not correlated to our body anything. So I think something that will correlated to our body, the test itself, it will be more complicated because we have to adjust to the body, which is the receiver of the food or anything that is in contact with the food packaging or like that packaging, something like that.
Yeah, but since the chitosan, also chitin, we can say it as the derivative of cellulose, yeah. And cellulose are very compatible with our body. Even we eat rice, also cellulose. Yeah, we don't need to be worried about the biocompatibility. This year, I been prepared a kind of wound dressing materials for anti-inflammations, yeah. Applications, and yeah, it prepared based on chitosan, and we haven't yet arrived to the biocompatibility test, but in case of not biodegradability, yes, we've been checked, and then for antibacterial properties, yeah, we also been checked, and yeah, it show how to say remarkable result, yeah, in case of antibacterial properties, which is chitosan is quite powerful to be used.
Okay, thank you, Bu Fitri and Arun. I think it's a nice discussion, yeah, related with this chitosan biomaterial. All right. Thank you, Arun, for the presentation, and also Aslan for the question. Okay. I think we should move to the next poster. I would like us to the VSS 8, transforming carbon dioxide to carbon materials. Is there anyone of the members from the group? I think Ois. Hello, Ois. Okay. Because it's already 11:30. I think I would like to move to the other poster. And for the palm oil and circular economy, VSS 9. All right. I think, okay, Shafira Maharani. Yeah. From VSS 9, right? Hello, Shafira.
Yes, I'm from VSS 9.
Okay. Could you please present your assignment project?
Yes, okay. Wait.
Okay. Do you need help from the committee to share your poster?
Of course, the committee can help us.
Okay. What the title? Wait. Okay. Could the committee please help palm oil and circular economy? Yeah. Wait.
Is it your poster?
Yes.
Okay.
Yes, of course. Good morning, everyone. My name is Afrobias Firyohanasakti.
Okay, thank you. I'm sorry, Afrobias. I can hear your voice clearly.
Okay, wait.
Maybe your headset.
Hello.
Yeah, it's clear.
Okay, thank you.
Thank you, Putri.
Okay, my name is Afrobias Firyohanasakti, and with my partner Shafira Maharani. Today, we like to present our SFP with the title Palm Oil and Circular Economy. Palm oil has many applications in various fields. Some of them are in food sector, the oleochemical industry, and most recently in biodiesel. Indonesia is the largest region in the production of palm oil, especially in Riau. In 2022, it was recorded that Indonesia produced a total of 44.76 million tons of palm oil. Each palm oil will produce an average of 25 until 30% of the main product in the form of CPO or crude palm oil, while the remaining 70 until 75% is residue from processing in the form of waste. From the production of palm oil, waste is produced in the form of pressed fruit fibers, empty fruit bunch, oil palm shell, or palm oil milk effluent or POM.
POM is waste generated in the palm oil industry consisting of solid, liquid, and gaseous waste. POM is a complex material and has different composition depending on the processing of palm oil into crude palm oil or CPO. Generally, POM consists of molecular very high concentration of organic compounds such as free fatty acids, protein, carbohydrates, nitrogen compounds, and fat, and also minerals. POM is a complex waste which is not toxic but can increase waste which is but can increase organic compounds and can cause extreme pollution. The characteristic of POM depend on the production process and the raw material used. POM has high energy potential, but in general, it has not been used optimally. POM can decompose, and then this biomass decomposition process will produce biogas with the main content of methane gas, and this gas can potentially be a source of electricity or a power plant.
For a palm oil mill with a processing capacity of 60 tons per hour of fresh oil palm fruit bunch, it has the potential to produce POM which can be processed into biogas or power plants with a power of about 2 megawatts. In Indonesia, the construction of POM-based power plants has been started since several years ago. By using POM as electrical energy, it is a proof of real concern and commitment to environmental balance and sustainable development goals such as the circular economy by utilizing waste products from palm oil production, namely POM, to be recycled into new products such as biogas. To make biogas from POM, the first step is to collect POM from the palm oil production waste, and then POM is put into the digester tank to produce biogas in the form of methane, and the biogas results are then stored in the biogas containers for further distribution as a power plant or as a fuel. That's all from our presentation. Thank you.
Thank you very much, Afrabias and Shafira, for the nice presentation. Okay. Is there any question? Come on, for the other participant to the VSS 9, palm oil and circular economy. I think this is the first topic related to the circular economy, yeah, from the participant. I think it's very nice, yeah, because as we know that palm, yeah, Ibu?
I'm really curious to hear from other participants, especially from abroad, yeah, out of Indonesia, according to the palm oil prices, yeah. In Indonesia, almost, what to say, I guess already half year, yeah, Bu Amel. The price of the palm oil is incredibly expensive, yeah, due to many reasons, yeah. some reason mentioned is a kind of the global impact of the World War occur in Russia. Other reason mentioned is due to the high demand for biodiesel, and then yeah, the palm oil that usually used for cooking, yeah, then how to say converted, yeah, as the raw precursor for preparing the biodiesel. So I would like to know, yeah, from Malaysia, from Vietnam, or from other countries regarding to these issues. Anyone can share with us here? Up to now, I check in the supermarket is still high, yeah. And then how was the solution, yeah, that been applied in each country to solve this kind of issue? Because in Indonesia, other product of cooking oil based on other material is not so common, ya, Bu Amel. And even the price, for example, from the sunflowers, yeah, from other seeds, yeah, yes, we have here, but the price even incredibly expensive. So we haven't yet thinking about the circular economy, but how to make the cooking oil, yeah, especially the
Exactly.
it's getting cheaper.
Yeah, yeah.
Anyone would like to comment about these issues, please?
Yeah, maybe from the other countries can update the condition, yeah, because I think not only in Indonesia we got the effect for this condition, but I think some of the countries in the Europe because some of they take the palm oil or sunflower from the Ukraine, yeah. But how about maybe from Pakistan and also from the Vietnam and Philippines? Is in your country got the problem also related to the cooking oil? Maybe I would like ask to Hong An, Dandi Akbar. Hello, Dandi. Okay. Maybe I would like to ask from Vietnam, Hoàng An. What do you think in Vietnam about the price for the for the cooking oil in Vietnam? Hoàng An. Hello. I think Hoàng An not in the meeting, or okay. Maybe I curious it. Maybe Saliha Khalid. Hello, Saliha Khalid. Hello. Yeah. So the participants, maybe Akib Talib. This is our previous participant last year, yeah, in VSS, I think. Hello, Akib. Yeah. Hello. All right. Maybe okay. Maybe before we answer the question from Gita, I would like to invite Priya. Maybe in Malaysia, is it the same in Indonesia?
Yes, yes, Miss. Yes, Miss. Can you repeat the question again? Sorry.
Yeah. How about the price for the cooking oil in the Malaysia? Is it increased because of
yes.
this condition?
Yes, it has increased. Yes, increased greatly around like previously it is much more lower, but recently it has been increased due to the crisis. Yes, it has increased.
Yeah, because in Indonesia, we got the twice, or maybe before we, for example, before we can got 20,000, but now for 1 liter we should pay for 50,000. So it's very expensive for us to cook, yeah, in home. So I think it's for other countries got same problems also, Bu Fitri. Yeah, maybe we can in the chat box we have 2 questions for VSS9. Yeah. Same with Malaysia, we use air fryer. All right. So we don't need cooking oil, yeah. If we use the fry air. All right. We should move to the question.
Air fryer could be the good alternative, but it consumes a lot of energy for electricity.
Yeah, the electrical, ya Bu ya.
Yeah, the electricity maybe
It's
consumption is
very
getting improved. But anyway,
what should we choose? What should we choose?
Stop cooking.
Stop cooking. So just eat salad maybe. Don't fry. All right. There is a question for VSS9 from Vita. Palm oil factories release waste in their process. How to deal with palm oil waste? Yeah. Okay. Maybe Afrabias and Shafira can answer this question. How to deal with the palm oil waste?
Okay, I want to answer it.
Yeah.
The palm oil for liquid waste will be it's produced, it's processed, it can to become a source of electricity and also stove.
Safira? I think Safira said that the waste of palm oil could be produced for the biofuel, maybe, yeah, or other source for the electricity energy. I think. I'm not sure because I can't hear clearly. All right, maybe we can move to the next question from Hendra. For circular economy, palm oil waste to biogas, it has already used or it's the new innovation? The committee, please mute the. All right. Basically, because of the waste palm oil, it's already used for the biogas. Is it a new innovation or it's just it has already used before? Safira and Afrabias, what do you think?
Circular economy palm oil waste to biogas actually already being used in Indonesia as an electrical source. In Jambi, there's a pembangkit listrik tenaga biogas if it's translated in Indonesia.
Okay, all right. Thank you, Afrabias. So basically, it's already used for the electrical power, yeah, energy. Okay. So in Thailand, it's also similar high price of cooking oil. All right. I think all of us facing the same problems, but we just wait for the salary to increase also, yeah. So we can buy this easily. All right. Thank you very much for the VSS9 and also for the question from Vita and Hendra. All right. Actually, we have a best at 10 best poster, but I would like to give I would like to invite for the 5 others poster that from the 11 under 15 who want to present the poster. Maybe I will give the 2 of you. Please raise your hand. So VSSF. Okay. So there is a Wita. Hello, Wita.
Hello, Miss.
Okay, okay. Yeah. From what group, Wita? VSS.
Wastewater treatment group 2.
Okay, wastewater treatment. So innovative wastewater treatment, yeah. Okay. Do you want to share screen by yourself?
Maybe by committee.
All right. Please, Bu Vidya or Bu Tri, would you have the Wita to share?
Is it your poster, Wita?
Yes, Bu.
Okay.
All right. Please
Okay.
Present, Wita.
Okay. Thank you for the opportunity. Good afternoon, everyone. Peace be upon you. I am Wita Putri Nirwani and my partner, Kak Aslan Irunsah. We are from Group 2 of the Innovation in Wastewater Treatment. This morning, we would like to present our poster. Here, we raise up this topic based on the anxiety we observe in our environment and also in other areas of developing countries, such as in ASEAN countries, Indonesia, Pakistan, the Philippines, African countries, and other countries over the globe. We can say that almost all developing countries experience the same environment issue related to availability of clean water. So, ladies and gentlemen, allow us to explain about the use of nanowire titanium dioxide on filtration membrane in wastewater treatment to meet clean water availability in areas with limited clean water sources. First of all, the need for clean water and hygienic water sources in developing countries is very urgent to be fulfilled. This is because most of the existing water sources have been contaminated by pollutants such as microbiological organisms, bacteria, viruses, organic and inorganic compounds. So that the water can be directly consumed for daily needs. The direct use of polluted water is very risky to human health. Based on data from the United Nations Development Program, UNDP, that around 884 million people in the world do not have access to clean water supplies. In addition, more than 14,000 people die each year from water-related disease. Ironically, every 1 minute, a child dies from water-related disease. Can you imagine such thing happening around us? We still do not aware and doing nothing related to it. Therefore, we try to solve this issue by removing pollutants from wastewater to meet the needs of clean water in the community, especially in areas with limited sources of clean water. We can use membrane filtration technology to solve this problem. The filtration membrane can filter unwanted pollutant from polluted water based on a such exclusion process. This membrane filtration system has some advantages, including being able to run automatically, requiring fewer chemicals and more flexible modular design. To optimize the performance of the membrane, we need a membrane material. One of the potential material to be used as membrane filtration is titanium dioxide. Titanium dioxide provides some advantages, such as its high chemical stability under acidic and alkaline conditions, inert to animal and human, so it is non-toxic, relatively inexpensive, and is an oxidizing agent that is safe from the environment, said by Ameta in Ameta 2016. Titanium dioxide exists in three forms of crystal structure, namely anatase, bruchite, and rutile. The anatase structure is selected for photocatalytic activity purpose. Interestingly, in the presence of light, titanium dioxide shows high oxidizing power, which can decompose organic and inorganic compounds even at very low concentration. So the use of titanium dioxide in the membrane will increase the ability of filtration membrane to filter pollutants while being safe from the environment and living things. Some recent studies that proven that titanium dioxide can remove pollutant in the form of bacteria such as Escherichia coli bacteria by Abidi et al. 2020, Vibrio visceri bacteria by Baniamerian et al. 2020, viruses such as hepatitis virus by Jen et al. 2007, influenza virus by Mazurkova et al. 2010.
Let me continue the presentations. Can you up the poster, please? Yeah, up one. Okay, thank you. Well, for the purpose of a filtration stance with titanium dioxide membranes with light catalyst, we need some devices. As you can see on the poster, we need photoreactors, UV sources, pumps, pressure sensors, weighing devices, and a computer. First of all, the process is that liquid waste flows into a photoreactor that already contains titanium dioxide nanowire membranes with a pump. Furthermore, with the help of UV lamps, all harmful components such as bacteria, viruses, etc. present in the water will be filtered and decomposed in the photoreactor. All these components will be held by the membranes, and only water components with the small molecules can pass through the membranes. The filter results are then pumped into a storage container that has been equipped with a scale by first passing through the pressure sensor. Data from pressure sensor and scales are then processed by computer for further purposes. As you can see on the poster, the results of the same image after the filtration process reveal that there were accumulations of fouling or impurities on the surface of the membrane without UV radiations. However, the accumulations of impurities didn't appear on the membrane surface with the UV irradiations. This indicates that titanium dioxide membranes works well under UV light by absorbing all impurities in the process of wastewater. Furthermore, to evaluate the presence of impurities, we can assume transmembrane pressure, or TMP, as a function of a nanowire membrane time with and without UV irradiations. The result shows that the TMP of the titanium dioxide nanomembrane as a function of a filtration time increased rapidly after 7 hours without UV radiations. Meanwhile, the poster should be okay. Meanwhile, the TMP of the titanium dioxide membrane with the UV radiations remain constant after 30 hours of a filtering time. The constant TMP throughout the durations of the filtrations time revealed that the impurities of the titanium dioxide nanomembrane didn't occur. This is because the impurity formations was inhibited in the presence of the titanium dioxide. As the results of the experiments, nanowire titanium dioxide on the filtrations membrane could inhibit the occurrence of impurities in the form of viruses, bacteria, organic and inorganic compounds in the water, so as to improve the quality of the filtered water. Seeing the potential of titanium dioxide as the oxidizing agent in destroying of viral cells, it's very possible that titanium dioxide-based membrane are also able to filter and destroy the COVID-19 virus. Well, the final goal of this experiment is the filtered water can be purified and consumed by the community, especially people who live in areas that lack clean water sources to meet the need for clean and healthy water. Ladies and gentlemen, before we finish our presentations, we would like to state that by solving the wastewater issue as explained, we directly contribute to achieve SDGs goal and number 6 related to improving water quality and etc. And at the same time, we also solve the problem of SDGs number 3.2 related to reducing the mortality rate in terms of water-related disease. And also SDGs number 11.6 related to municipal waste management. That's all our group presentations. Thank you for your kind attention.
All right, thank you very much for the VSS 15 innovation. I don't know what the group you are, but I think it's very nice because it's about the wastewater treatment, yeah, from the titanium oxide, and so I think there's a super powerful materials for the water treatment. Okay, maybe is there any question for the participant related to the topics? Okay.
I have question, Bu Amel.
Okay, Bu Fitri, please.
Thank you, Aslan and Wita, yeah, and friends in this group of very interesting presentations. And I'm really curious with how to say the titanium oxide. I don't know, it's a kind of membrane that you prepare by electrospinning processes or method. Because from the SEM images that you just presented, yeah, the fiber morphology was so nicely demonstrated. So my questions: how the titanium oxide membrane, yeah, was prepared in this study?
Well, actually, ma'am, we just did a literature review for the presentations because we lack of time to prepare. So we read several papers to find the best title for our presentations. And I think there are many ways to produce titanium dioxide. And in our poster, we just mentioned the potential of the use titanium dioxide to be used in a filtering membrane in order this technology can be used in rural areas. Actually, several research have been conducted in the laboratory, but the implementations in the society is still not seen actually.
Yeah, that's right. If we consider about the technical aspect and also the economical aspect, yeah, it's quite challenging, I guess, to use the titanium oxide because in terms of prices, it's not cheaper. But yeah, in terms of performance, yes, it's quite powerful. As I know, titanium oxide also commonly used as the photocatalytic materials, right?
Yes, ma'am.
Titanium oxide, yeah. I'm not sure if in this system, the mechanism that was occur on treating the wastewater or the polluted water is also, how to say, occur by the photocatalytic mechanism or so on, because yeah, in your presentations you employ titanium oxide, and then I'm not sure if is the titanium oxide in the membrane is the main materials or just coated to the membrane materials. Yeah, my opinion, high possibility, because titanium oxide is not cheap, yeah, to be prepared as the membrane precursor. High possibility the membrane itself prepared from the inorganic or organic precursor. For example, if we choose the inorganic materials for the membrane precursors, it can be a kind of ceramic, clay, yeah, or other, but then titanium oxide coated or doped or encapsulated in that material. But even though I do believe the performance of the membrane later on will be great, because yeah, as I mentioned, titanium oxide can, how to say, contribute the photocatalytic activity that can be also useful to degrade the, for example, the organic pollutants such as dyes and so on. Yeah, and by employing UV light, for example, the photocatalysis mechanism will be occur in this separation system. Yeah, that you just presented nicely. Maybe that's my my opinion, because yeah, it's too, how to say, too expensive, I guess, if all membrane material only based on titanium oxide. Yeah, thank you, Aslan. Very good presentation.
Thank you, ma'am.
Okay. Thank you, Bu Fitri, for the nice discussion. All right, is there any question to Aslan and Wit? If there is no question, I think I would like to thank you very much to Aslan and Wita. It is a very great presentation. Yeah.
Yes,
Yeah, Ibu.
short information for all participants here. This year I'm working with the preparations of photocatalytic materials, Aslan, and we just prepare a kind of titanium oxide, but I didn't employ titanium oxide. I use even the cheaper materials such as zinc oxide, yeah, nickel oxide. We selected this material based on the band gap of this metal oxide, which is also how to say, exhibit the good semiconductor properties, yeah, and it would be suitable for photocatalytic degradations. And yeah, I would like to share quickly about our recent result. We prepared the composite of nanoparticles, zinc oxide and nickel oxides at certain composition. Later on, maybe after accepted, I will share the paper. But anyhow, we employ this for the photocatalytic degradations to remove several dyes compound. Yeah, for example, like methyl orange, yeah, methylene blue, or even though, for example, rhodamine B that how to say, represent as the cationic and anionic dyes. And very fortunate, we have the good result on this removal efficiency, which is it goes over 92% of the dyes removals. The system is quite simple, but almost similar with the one that Aslan and friends just presented to us. We synthesize it in the powder form, and then we just mix it with the how to say, solution model, that we reckon as the wastewater. at the certain concentrations of the compounds inside. And then we just mix it under UV radiations. So in this study, we choose UVA and UVC, yeah, as the resources for the radiations, and then we keep it for certain time. And after that, we check. We can see easily from the reducing the color, yeah, of the solution model. And then after that, we check by UV, and then we can calculate later on for the degradations efficiency. That's very easy, very simple one. But the one that just presented by Aslan, yeah, is even more advanced, because at that review, the titanium oxide was embedded in the membrane, and then it fixed it into the the filtration system, yeah. The how to say, the feed water flew to the membrane, and then later on the separation will be occur. And I guess you also employ the UV light, yeah, to make sure the removal as well, not only the water pollutant, but also maybe the microorganism that still exists in the water. And by the end, you will obtain the clean water as you expected. I guess like that, right?
Yes, ma'am.
Yeah.
We mentioned in our presentations, we use a UV lamp.
Yeah. That's also common in many processes for the water treatment. So maybe that's my brief sharing. Yeah, for the one who love with the metal oxide, yeah, just work it with that how to say materials. And yeah, in my best idea, you can shift, yeah, to the cheapest one, yeah, of the metal oxide. So as Aslan mentioned, for the motivation, if we would like to the feasible innovations, the cheaper one, the easiest one to be prepared, I guess would be the most feasible one to be applied, to be adapted by the society, yeah, especially for solving the problem on the water treatment. Thank you, Bu Amel. Thank you, Aslan.
Thank you, Bu Fitri. Thank you, Aslan, and thank you, Wita, for the nice discussion. Yeah, maybe it's very insightful. Yeah, thank you, Bu Fitri, for sharing to us. All right. I think the session for Aslan and Wita is enough, and thank you very much for the nice presentation, Aslan and Wita. Maybe we will move to the last, yeah. I would like to invite one group for the last presenter. Maybe if you want to share about your project, please raise hand for the last presenter. If we don't have the volunteer, I think we can move to the voting, yeah, for the appreciation for the participant. All right?
Yeah. Who are eligible to do vote? If the committee also eligible?
Yeah.
All right.
The committee eligible to vote for the best speaker, for our best speaker today. Yeah. Okay. Is there any group want to share the project? It's if you are not in the list of the 10 of the poster, it's okay. You can raise hand and you can present your poster. While we are waiting for the Bu Filia to prepare the voting. Yeah. All right. Yeah. Okay, I think there is no volunteer. Maybe we can move to the next agenda to give the voting, yeah, for the best speaker. Yeah, actually, best speaker is for all of who already explained the presentation for today's meeting. That consists of some of group, but not all of you. but just for the already give us the explanation of their projects. Okay, please join the slide. All right. Please, all of the participants join the slide. The link already in the chat box. For all of the participants and also the committee can vote the best speaker for today's session. So make sure. You vote for the best speaker, yeah? Okay, sorry. Voting going slide. It's 32. We have 45 participants in this Zoom. Please, come on. This is our last meeting. So maybe this is our last slide session. All right. We have 34. We have joined. Okay. All right. So we have 1, 2, 3, 4, 5, 6, 7. 7 presenter, yeah. Please choose one of the best presenter.
I think Bu Amel can give instructions so I can start the voting. Yeah, because it's still locked.
Oh, okay. So basically, if you want to vote the best presenter, you just click. Yeah, you just click or choose one of these presenter. Yeah. If you
Only one, Bu Amel?
Yeah.
Only one vote? Can we vote more than one?
Yeah, just one. One person, just one.
It would be
So do you want to
difficult
vote
in
more
such
than one? I think I have to change the. So
Yeah.
actually you can vote more than one, but I have to change the setting. So if you could please wait, so I have to change the setting first.
Yeah.
So
Maybe
you can all
we
can.
we can
Do you
choose
want to? Yeah.
three best poster.
Okay, so
Yes,
please.
yes, at least
Yeah, so
three.
please
At
wait.
least
I
three,
think yeah.
because all is great. So it's quite difficult to
Okay, so I
decide.
have to change the setting for a moment, please.
Yes,
Okay.
yes,
Yeah.
don't worry.
Just
Thank
please
you,
do
Bu
it.
Fidi.
Thank you, Bu Fidia. Yeah. All right, because I agree with Bu Fitri. All of the speakers are great, and the topic is also very nice. And as I said before, it's beyond my expectation because just for 1 week, you can review some papers and make it to the posters. Wow, it's a very good, yeah, very nice. I think so. Thank you for the effort, yeah, to do this assignment.
Yeah, this really excellent and also how to say wonderful. Yeah, I deeply how to say appreciate and always amazed, yeah, with the participant effort. Yeah, it less than 1 week actually, Bu Amel, since we
Yeah.
kick off the program on Monday. Yeah, and on Wednesday the committee already asked for the poster submission. Yeah, it's amazing. It's amazing, and even today they presented their own poster. Very wonderful. So congratulations, yeah, to all participants. Thank you so much for your great contribution, yeah, for this summer school.
Yeah.
And
So Ibu Amel.
it's ready now.
Yeah, so I have All changed right. the setting. You can pick more than one, and then each participant can pick up to 3. So So you you can right. choose 3 favorite group speakers. Yes.
Okay.
So maybe Bu Amel can count to 3 so I can start the voting.
Okay.
Alright.
Okay. Everyone is ready?
Ready.
So I can I can count from 3, 2, 1. Go. Please choose the best speaker. Yeah, wow. So this is very tight between VSS 1, 2, 3, 4, 5. You.
No music?
Music.
Yeah. To release the how to say.
Please, 4, 3, 2, 1. All right. About the result. I think it's already done. Yeah.
Yeah, so that you can see the result is there.
Okay.
The highest.
So the highest, yeah, from VSS1. Okay, from VSS1. So there is 27.87%. Okay, and the second one is from VSS3. Congratulations first from VSS1. Give applause. And the second one is from VSS3, effective microorganism, yeah. Give applause first VSS3. And the third is from VSS2, Ketusan-based biodegradable film for packaging application. Give applause for the VSS2. But for the other groups, it's also excellent, yeah. It is just for fun, yeah. This is just for fun, but from discussing we get a lot many knowledge, yeah, from several topics that you already explained for us, and so very nice. I think we should give all of us applause. We did a great job, everyone. Thank you very much. All right. So, is there any voting or other Bu Vidya or Putri?
From me, it's very enough. And thank you very much for the all participant who has joined with this third virtual summer school. Hopefully we will have fourth virtual summer school, Bu Fitri. Yeah, so please waiting for the next virtual summer school. Thank you, Bu Amel.
All right, thank you, Bu Tri.
Regarding the next virtual summer school, just a spoiler to all participants who attend today. So our department last week, how to say, has made intimate discussions with other institutions, yeah, with the Institute Technology Indonesia. Some of Indonesian students, I believe, now this university, and yeah, they really curious to how to say, to organize a kind of joint virtual summer school, and yeah, high possibility it will be conducted next year, and the theme or the idea of this summer school will be more engagement with industry, yeah. So hopefully it will be a great of all of your interests, and in my opinion, the concept of the next virtual summer school, yeah, will be related, of course, to chemistry, but as well we have more great engagement with the applied chemistry, especially in industry. So there will be many speakers, experts from industry that will be the invited speaker. Yeah, hopefully we can, how to say, deliver the new environment for for the future participants, yeah, in our future summer school. So just the fresh info. We will update, I guess, the progress later. And I do believe we already have the contact via Telegram or WhatsApp, yeah, Bu Amel. And yeah, later on we will inform about the next plan, yeah, especially for the next year virtual summer school.
Okay, thank you very much, Bu Fitri. I think this is the end of our meeting today. Maybe it's already we have a closing remarks from Bu Fitri, and from the committee. On behalf of the committee, I also want to express my gratitude and also thank you very much for all of the participants who already joined our VSS course. And I think this year topic is very interesting and it's a very related to us, especially not only for a chemist, but also for others major, yeah, maybe from the engineer and environmentals and etc. So this is a very nice topic, and thank you very much for all of the participants who already joined and the active participating since Monday, yeah, technical meeting, and then today, and also thank you for the posters, activating, asking to the speakers, and also always join our quiz session. So it's a very interesting. But before we close this meeting, actually the committee already prepared the certificate. So we will send to you all through your email that already registered to our system. And also for the credit earning, maybe Bu Vidya will be announced later in the group Telegram. So make sure you join the Telegram. Yeah. All right. Before we close this meeting, we should take a picture. Yeah. Our last picture together. Oh, okay. I'm sorry, I forgot. Before we take a picture, I would like to invite one of the participants who want to give the testimony for this virtual summer school, or maybe you have an idea for the next topic, the next year VSS. Maybe you want to please give other topics, so it can give us some of idea, yeah. Okay, please, one of the participants maybe. Who want to say something? Maybe you want to say something about this VSS? Could I choose one? Aslan. Okay, Aslan. Thank you.
Well, I would like to say it's very enjoyable to join this summer school. I learned a lot from this summer school, and I'm totally glad to be part of the 2022 summer school. The lectures were very informative from the first day until the day before yesterday. Yeah, I know the participant never stopped asking questions every session. And the poster assignment was quite challenging and also gave us more pressure because we need to finish it in a very short time. Moreover, we lack of persons in our team, so that's all what we can do in our roster. To be honest, there are some needs to be improved from the summer school, but I believe those things can be a good resource for all of us for the upcoming summer school. The last, I would like to say thank you to the committee of the summer school, and thank you to the Department of Chemistry Educations, the University Educations, to be successfully organized this fabulous 2022 summer school. Thank you.
Thank you, Aslan.
Okay. Thank you very much, Aslan. Thank you very much. Yeah, it's very nice to hear this opinion from you, and I think we can improve the other in the next year maybe. Okay, I think Safina Ali is right hand. Hello, Salina. If I'm not mistaken, Salina Ali, right?
Hello, ma'am.
Hello, Salina.
Hello, ma'am. Am I audible to you?
Yeah. Yeah,
Okay.
please.
So, firstly, thank you to all of the committee members for arranging this beautiful and informative summer school. The only suggestion I would give is to please do give a choice of selecting the group the members want to select, as that would be more informative. The one having expertise or studies in the relevant field can choose that and can better explain in the QA session what they presented. So this is the only comment that I would suggest.
Yeah.
Thank you, Salina.
Thank you.
Fitri.
Yeah, thank you, Safina, for your great suggestions. It would be very valuable for us to manage, yeah, in the future for our Pitwa Summer School. Yeah, your idea is great. Yeah, how to make more fruitful discussions. It's better to arrange the participants within the appropriate group. Yeah, that then yeah everyone can share the idea. How to say optimally, yeah. And also to Aslan, I more than pleased to hear your comment. Thank you so much. And yeah, we are more than grateful to hear that all of you enjoy and feel the benefit of this program, because that's the main target of this activity. And of course, on arranging this program, we still have many shortcomings technically or substantially. We realize that, and yeah, from your suggestion, your thought, we will try our best to improve, yeah, how to manage this program. And yeah, I'm very looking forward to see you all again in our next Pitwa Summer School, or even in our other occasions, because our department actually is quite very active, yeah, on organizing or arranging several types of the, how to say, scientific or academic activities, such as the guest lecture series, webinar series. Yeah, even in the near future, on next month, I have a grant from the World Class Professor Program, which is specially facilitate I and my collaborator to arrange many good activities, especially for students. Yeah, I invited the professor from University Science Malaysia, Prof. Lim, who are very expert on synthesizing nano materials. So for the ones who are interested in, please wait for our, how to say, soon advertisement regarding to this program. Yeah, and also other activities that especially organized by our department. So I would be very pleased to meet you again, yeah, to seeing you again in other occasions. So thank you so much, yeah, and yeah, very looking forward for your best success in study and also in research. I have some connections with the participant here, and for the ones who wanted to
have more connections with our department and with me in personal, I can provide my contact in the chat room. So for your information, besides a chairman of this program, I also has the appointment as the head of study program of chemistry. So if you want to know more about our study program and other opportunity, for example, for the student exchange or for scholarship or so on, so please kindly feel free to contact me anytime. I would be very pleased to reply your email, your message, and etc. And again, maybe Bu Amel and everyone, before I forgot, I would like to call all participants to give the big applause for the committee in floor, Bu Amel, Bu Vidya, Bu Tri, and then Pak Hafid, Pak Mora. Without them, I guess I could do nothing. Yeah. Especially the heroes behind is the people, the people, the people heroes. So thank you. Please give our big applause for them once more. Everyone, you can put your reactions on the on the Zoom. Yeah, and also big please send our big love for them, and thank you so much for your great effort, my beloved committee. And again, I would also like to deliver my great appreciations and my thankful for all participants who did a great job during this summer school. Yeah, I didn't even how to say expect that your effort would be very excellent. Yeah, at this moment. So thank you so much. Thank you so much. It's deeply appreciated. Thank you, Bu Amel.
All right. Okay, thank you very much, Bu Fitri. Okay, all right. So we have Salihah Khalid, is a biochemist professor. And okay, thank you. So we have other connection, yeah, collaboration. Actually, oh yeah, before we close the session, we need, I think we should take a picture together for the last time. So I hope all of you can open your video, yeah, so we can get complete, yeah, the last. All right, please turn on your camera.
So this photo will be displayed on our department website.
Yeah.
So everyone, to the one who wants to be famous quickly, so please open your video, your camera. Later on, yeah, we will display this photograph in our department website as the summary of our virtual summer school program.
Okay. And also of the poster, yeah. I think I would like to post in the website, our website. So,
we will call this as the alumni of virtual summer school program 2020. Yeah.
Yeah, great. So if you want to, if you miss us, you can visit our YouTube channel. Also, don't forget like, comment, and subscribe. So I like a YouTuber right now. So okay, I think Bu Vidya, could you please take a picture for us?
Sure. So everyone, please be ready. We have two pages here. Okay, for the first slide, please smile. 1, 2, 3. So the second one, okay. Please smile. 1, 2, 3. Okay. It's
No
done. Thank
freestyle? No
you.
freestyle?
Okay. Okay, one more time. Freestyle then. So please pose as much as you want. Okay,
Like
for
this?
the sure, Ibu. Okay,
Oh, sarannya.
1, 2, 3. Okay, the second one. 1, 2, 3. Okay, thank you, everyone.
Thank you so much.
Okay. Thank you so much. Okay. All right. Thank you so much, everyone. I will post the picture to our Telegram, yeah, so we can share the moment in Instagram. You can also tag our Instagram, the team UPI. So so the admin will be repost your post, yeah. All right. I think this is our last agenda. So, as I said before, we thank you very much for all of you join us to this course, and thank you very much for all of the active participating, and also from the committee. We have many mistakes, so I do apologize for many inconvenience maybe. I hope we can meet to the next VSS, to the next year VSS. We have the other topic, yeah, and I already give the link, yeah, Google Form in the chat box, and I hope all of the participants could fill out the link. It is we count the attendance link, and also we need the feedback for all of you related to our VSS, and also what your suggestion for our next year VSS. Okay, actually this is our third VSS, and it's very grateful to running this program. Okay, thank you everyone. I hope all of you in this good health, and also and always success in every major and every in your university. And see you next year maybe. Bye.
See you, everyone. Yeah.
See you, everyone. Thank you, Ibu Amel, Ibu Fitri, Ibu Vidya, and everyone.
Bu Tri, Bu Vidya, Bu Fitri.
Bye-bye, everyone.
Bye. Thank you, Aslan.
No
Priya,
music, Bu Vidya, no music.
Zarina. Yeah, thank you, Bu Mita. Thank you, Misa Liha. Thank you, Nafran. Thank you, Nana, Arum, Ryan. Thank you very much. Maybe Putri can share some videos. Okay, thank you, Miss Aliha. Thank you, Nana. Thank you, Satria. Thank you, Ilham. Thank you, Hong An. Thank you, Hong An. Maybe next year you can join again with Trung, yeah, Trung. Thank you, all of the participants. We love you. Thank you. Thank you. Thank you, Siti Roga. Thank you, Aprabias. Thank you, Fataria. Thank you, Hong An.
Indonesia, tanah kelahiranku, nan indah kebanggaanku. Di sini ku berdiri, ikrarkan janji olehmu negeriku.
Thank you, you, Nina, for
Suci
the
dan
presentation.
abadi negeriku, jayalah bangsaku, selalu engkaulah yang ku cinta.
Segenggam harapan, sejuta mimpi ingin ku abdikan padamu negeriku.
Let's sing together.
Untukmu Indonesia, jayalah negeriku, bangkitlah bangsaku, angkatlah panjimu, satukan mimpimu yang tak akan padam, menggapai cita adil dan makmur, sejahtera Indonesia. Jayalah negeriku, bangkitlah bangsaku, angkatlah panjimu, satukan mimpimu yang tak akan padam, menggapai cita adil dan makmur, sejahtera Indonesia. Jayalah negeriku, bangkitlah bangsaku, angkatlah panjimu, satukan mimpimu yang tak akan padam, menggapai cita adil dan makmur, sejahtera Indonesia.
Thank you, Rizky.
Pada bendera merah putih.
Hormat.
Indonesia tanah airku.
Very nice song. I just watched it.
Meninggalkan tanah air pada tanggal 1 April yang lalu.
Thank you, Bu
Kami menyerahkan
Fitri.
keselamatan
Thank you,
negara,
everyone.
tanah
Thank
air,
you.
dan
Have a
bangsa
great
ini
day.
kepada seluruh rakyat Indonesia.
Alhamdulillah.
Selama kami di luar negeri, kami memperhatikan benar-benar segala kejadian-kejadian di tanah air. Dan kami memperhatikan pula segala
Still some participant here, right? So
Yeah.
seems no no one would like to leave.
The songs.
Iya. Ibu Ngatiem.
Hanya bilik bambu, tempat tinggal kita,
Yes, indeed,
tanpa
that's right.
hiasan, tanpa lukisan.
Ya, kita karaokean aja.
Yo.
Jerami, beralaskan tanah.
No,
Namun semua ini punya kita. Memang semua ini milik kita sendiri. Hanya alam-alam agar rumah kita tanpa nyali, tanpa melatih. Hanya bunga bakung tumbuh di halaman. Namun semua itu punya kita. beranjak ke kota yang penuh dengan tanya. Lebih baik di sini, rumah kita sendiri. Segala nikmat dan anugerah yang kuasa, semuanya ada di sini. Lebih baik di sini, rumah kita sendiri. Segala nikmat dan anugerah yang kuasa, semuanya ada di sini. Rumah kita, rumah kita, rumah kita.
All right, bye-bye everyone. Thank you so much. Mwah. Bu Amel pamit, Bu Amel.
I think we should end this meeting, yeah. See you.
See you, Bu Amel. Have a great rest, everyone, and a good day, and all. Yeah, all best for you.
Yeah, amin. Thank you, Bu Fitri. Have a great Sunday. Have a great weekend.
Amin.
See you. Presentation. Offline or online? See you.
Tanah airku indah.
Maybe after this song we can end this meeting, ya Putri.
Negeri elok amat ku cinta.
Yes, Ibu Amel, sorry.
Maybe after this song we can end the meeting.
Okay.